Hey guys, this is Coach Lowe, and we are going to talk about postulates and paragraph proofs. This is Chapter 2, Section 5. Today's recording will be mostly just writing down postulates and giving some examples. We'll talk a little bit about paragraph proofs, and then we'll hit those pretty hard in class when I see you again. So let's look at postulates and paragraph proofs. So first of all, a postulate, when you hear me talk about a postulate, you should know that it's a statement accepted as true, and we don't have to prove it. So when we write these next postulates down, we know that they're true. We accept them as being true. We don't have to go through a proof for them. So let's look at 2.1. So this will go in your postulate/theorem section, theorems and postulates. So you need a page for this. So 2.1, through any 2 points, there's exactly one line. So you can draw 2 points. If we want a little picture, you can draw 2 points and call those A and B. And there is only one line that you could draw through those 2 points. Now, if you have more than 2 points, of course, you can draw different lines through them. But line L here would be drawn through points A and B. All right, let's look at the next one. Through any 3 non-collinear points, there is exactly one plane. So we've talked about this before. I have a plane here, and I have 3 points that are not on the same line. Now you can draw lines through 2 of them, and that's fine. They just can't be lined up on the same line, and that forms a plane, and we'll call this plane K. All right, a line contains at least 2 points. A line can contain more than 2 points, but it contains at least 2. So at the least, we can have 2 points, but of course we can have more than 2. When we name a line, we name a line either by the subscript letter or with 2 of the however many points there are. It doesn't matter which 2 you choose, but you can choose any 2 points. So line L contains points R, S, and T in this case. Line L contains points R, S, and T. Line L contains points R, S, and T. All right, let's look at 2.4. A plane contains at least 3 non-collinear points. All right, so there can be more points than just 3 in a plane, but when we name plane R here, and let's say A, B, C, D are all in the plane, and I have 3 non-collinear points, or I have more than 3 actually this time, you can choose any 3 of those points to name a plane. So points A, B, C, and D lie in plane R. Or we can say plane R contains non-collinear points A, B, C, D. All right. 2.4, let me just scroll down a little bit. 2.4, if 2 points lie in a plane, then the entire line containing those points lie in that plane. So you kind of have to think about this a little bit. If I draw a plane here, let's say that this is plane T, and I have 2 points that are in the plane. Let's call those A and B. If those 2 points are in the plane, then the line that goes through them is also in the plane. And you can think about, remember we talked about with planes, you can continue to stretch those things out. So as the plane continues to stretch out, that line would continue to stretch out. And so that line will stay in the plane the entire time. All right, intersections of lines and planes. 2 lines intersect. If they do, then their intersection will be exactly 1 point. You cannot have 2 lines intersect and they intersect in more than just 1 point. All right, now we know that they can be parallel and never intersect, but we're talking about if they do intersect, then they will intersect at exactly 1 point. All right, let's get back to that. All right, so I have lines M and N, and they're intersecting here at point T. All right, let's move on. The next one, if 2 planes intersect, then their intersection is a line. And you could think about, we've talked about this before, to think about taking 2 pieces of paper and you can cut one of those pieces, or even you could cut like halfway on both of them and slide one inside the other, and you can see that their intersection is really a line. All right, so two planes intersect at a line. All right, now for a theorem. So notice we've switched gears. Those last 7 were postulates. Now we have the midpoint theorem. If M is the midpoint of AB, then, and this is segment AB, because we can't find a midpoint of a line, so segment AB, then the distance from A to M is congruent to, or the line segment AM is congruent to MB, which means the distance from A to M is the same length as from M to B. All right. So when we get back to class, guys, we will talk about some paragraph proofs. I'm going to give you just a little preview of that, and then we'll do some in class. When we talk about paragraph proofs, they're also called informal proofs. And as we think about the proof process, it will look like this. You'll have a given, which is also called a hypothesis. All right, and then that will be our step 1, is figure out what the given is, and usually it'll say given, and then think about, okay, what does the picture look like? What theorems will go with this? Kind of check out what you're given, and then also we want to look to see what we're trying to prove. And so we want to begin with the end in mind. We want to look and see what we're trying to prove and think about the path to get there. So look at where we're trying to go. And that would be it'll say prove with it. All right. Number 2 step, we are going to, we're going to think about the theorems and conjectures that we can use. To get to where we want to end up. All right, so we'll make a list of those. And then the third step will be, all right, so we need to arrange our statements so that we have a logical progression from the given to the proof part. All right, so this is our deductive reasoning. So it's kind of like when you're in an argument and you say, okay, but this, then this, then this, then this, and you have a logical progression to get to, okay, this is what I want to do, this is how it should be, or now I've proved my point. All right. And as we pick up those statements, we'll justify each of those. And then finally, we will get to our prove part. We will have proven that. All right. So we'll look at the hypothesis, see where we want to go. We'll think about all the conjectures and the theorems that we can use. We will put those in order so that it flows from the given all the way to the prove part. We will justify each one of those, and then we will be finished and happy and high-fiving each other. All right, we will talk about this in class. You guys have a great rest of the day. It's a great day to have a great day. This is Coach Lowe, and I'm out.